Hello everyone, this is Poornima Deepthi, working as an assistant professor in the ECE department of MLR IT, Hyderabad. Today I would like to explain the features of 8085. So this series of videos is all about the 8086 microprocessor. Even though we are dealing with the 8086 microprocessor, we need to know the little about 8085 features. That's why today we are going to listen about the 8085 microprocessors features. So the important overview what I was dealing with today is data, how many data and address lines are there and how they work in the 8085 microprocessor and what are the architecture 8085 is using and how register sets are paid in this 8085 and what are the interrupts and how many interrupts are there in 8085. Let's go into the topic. So one of the most important feature of 8085 is it is a 8-bit processor. So what is a bit, why we are calling as 8-bit microprocessor, this all I have already discussed in the previous videos. If you didn't look into that videos before listening this topic, please look back into that videos. So here the important things in 8-bit processor means it need to support three things. First one is the ALU, which is used to perform the arithmetic and logical unit of 8085 must be of 8-bit, must support 8-bit, and whatever the internal registers we have been using in this 8085 is always 8-bit internal registers. And the last one is it need to access 8 bits for one machine cycle. So I have already told what is a cycle, what is the clock generating the cycles and how clocks related to the processor. So now we will be dealing with the ALU. How ALU is there? So what is the purpose of ALU? ALU is arithmetic and logical unit which performs arithmetical operations like addition, subtraction, division, multiplication, and the logical unit which is supposed to perform the logical operations like AND operation, OR operation like that. The ALU of any processor will be looking like this. So if we are considering this as ALU of 8085 microprocessor, it will be having two inputs. To perform any arithmetical or logical operations, we will be having two inputs apart from that negative, means a complement. Apart from that, we will be using minimum two inputs. So these will be having 8-bit inputs. And the output which we are getting from the ALU unit of 8085 need to support 8 bits. So this is all about the ALU of 8085. Now coming back to the internal registers of 8085. So what are the internal registers present in? What is the need of registers? Actually, the internal registers is used to store the intermediate values when coming between the operations. So that internal registers used to store the data which is coming in the intermediate level. So how many registers are there in 8085? Basically 8085 is consist of the registers A, B, C, D, E, H and L. These are the basic internal registers which we are having in 8085. Why I have wrote like this? Because there is one logic for internal registers of 8085. What is that logic means? If we are considering every register in 8085 need to support 8 bits. So it will be storing 8 bits. So a register is called as accumulator register, which is basically used to store the intermediate values and the outputs of the any operations will be automatically stored in accumulator. So this BC is considered as a one pair of registers which is be holding 16-bit data. So now one question will arise. So usually in the previous videos I told that 8085 is having only 8-bit registers. Then how the 16-bit data will be stored in these registers? So while manufacturing this 8085 microprocessors, it is necessary to perform 16-bit operations. Even though at that time, for 8-bit operations we can manually do it, right? So what is the purpose of doing 8-bit operations in microprocessor? So there must be one advantage. So as for that, a 16-bit applications will also be used. These 16-bit applications, 16-bit data, how it will be stored in registers. So in 8085 there is a pair of registers. So one register is used to store 8-bit of data, but the combination of these two registers will store 16-bit of data. So while we are using BC as a pair, then BC pair of register will hold 16-bit of data. How this data will be stored in BC? What is the lower byte where it will be stored, higher byte where it will be stored? So let us take one example of 16-bit data. Let us consider 3465 is our 16-bit data. So there will be one question. You are telling that 16-bit data and you have written only 4 digits. So as I already told you that in 8085 microprocessor or whatever the microprocessor I was dealing with, always is having the hexadecimal format. So how hexadecimal format will be represented in binary digits? 1 digit of hexadecimal will be taking 4 digits of binary representation. So how this 3 will be represented in binary? 0, 0, 1, 1. And how this 4? 0, 1, 0, 0. This will be using 8421 code. Okay. Now how is this 6? 0, 1, 1, 0. And this 5 will be represented as 0, 1, 0, 1. This is the binary representation of the hexadecimal digits. Okay. Now consider how we are using this 3465. How we are going to store this 16-bit data as a pair of BC. So 3465, when you consider 3465 hexadecimal number, the lower 8 bits or the lower byte, the byte which is starting from the right side will be considered as lower byte, and the digits having from the left side will be considered as higher byte. So as you all, I think you all know about the how data will be stored in memory as a binary data. Okay, fine. So as of now, the memory which we are using or will be using can hold only 8 bits of data in one memory location. Let us consider this location as 2000 location. In this location, only 8 bits of data can be stored. That means 1 byte of data only stored in one location of memory. So here this 65 byte will be stored in one memory location and 34 will be stored in another memory location. Okay. So the lower byte of 16-bit data will always be stored in C register, and the higher byte of the data will always be stored in B register if you consider BC register pair. Remember one thing, that's why I have already wrote like this. The BDH registers in the pair will act as the higher byte storage registers, and CEL is used to store the lower byte of the data when we are taking 16 bits of data. So these are the internal registers which we will be using in 8085 microprocessor. Now coming back to the 8-bit data in one machine cycle. As I already told you, the bit size of microprocessor, the data bus size of microprocessor will define the number of bits of microprocessor. Here the data bus which we will be using in 8085 is having 8 bits of data. So that 8 bits of data can be implemented or can be accessed in one machine cycle. It is necessary. So if we are going for the 16-bit processor like 8086, these 3 bits are these 3 points are will be also for 8086, but there one difference is there. Here it is a 8-bit microprocessor, there it is a 16-bit microprocessor. So in 8086 also, the microprocessor is a 16-bit microprocessor. So mainly it needs to support 16-bit ALU size, and it will be having the internal registers of 16-bit, and it need to perform 16 bits of data in one machine cycle. So for n bits of a microprocessor, n bits, it need to support n bits of ALU, it need to be having n bits of internal registers, it need to access n bit of data in one machine cycle. Okay, this is common for any microprocessor. Fine. Next, going to another important feature of 8085 microprocessor. The 8085 microprocessor always supports von Neumann architecture. Now, what is a von Neumann architecture? So, as I already told you, the data and program. So, you all know that a program is different from the data, right? So, these program and data will be stored in one memory. So, here the data will be stored in memory and the program will also be stored in memory. So, if in a von Neumann architecture, the memory is same to store the data as well as to store the program. That means if you are accessing the data, you can't access the program memory. If you are accessing the program, you can't access the data. It depends upon the data or program you need to fetch. And here if you see that from control unit and ALU unit, there is memory holding both data and program. Same memory is used to store the program and data. So these are the system buses which we are using to transmit the data between the blocks of system. So the another data is Harvard architecture. Harvard architecture. In Harvard architecture, the memory is divided into two types. First, one of the memory will be used to store the data and second memory will be used to store the program, right? So, there is two different memory locations. One is used to store the data and one is used to store the program. Here in Harvard architecture, you can access the data as well as program at same time also by using the different system buses. One is for data bus and one is for data memory and one is for program memory. So, how to inbuild this architecture in microprocessor? It totally depends upon the application you have been using this microprocessor or the compact size of the microprocessor. If we are going for the compact size, it will be recommended to use data and program memory. If your application need to have very highest speed, then you can be using this Harvard architecture. It depends upon the application, which architecture is used in your microprocessors. Next, going to the next one. So, one of the important feature of 8085 is it is used little endian rule. What is little endian rule? So, let us consider the same example which I have been discussed in the previous slide, that we are taking 3465 hexadecimal number, right? So, we need to store this hexadecimal number in a memory, right? If you need to access the data, it should be always stored in one particular location, that would be the memory. If I was considering this as a memory, and the memory location's address is important, right? To access the data of a particular memory, we need to have a unique address. So here I'll be taking the address location of this one is 2000 and it will be like 2001, 2002, so on. So in little endian rule, the data will be stored as the lower byte will be stored in the lower address region and the higher byte will be stored in the consecutive higher address region. Let us consider in this example 65 is the lower byte and higher byte is 34. So the lower byte need to be stored in the lower address location. Here what is the lower address location? 2000. So the lower byte 65 will be stored in the lower address location and the higher byte will be stored in the higher address location 34, consecutive higher address location. So 34. This will be followed in 8085. Most of the Intel generated processors will be having this little endian rule. The other processors is having big endian rule. I will be discussing this big endian rule next slide. So here in this particular example, there is two data, right? One data is this one and the second data is this one. See, the lower bytes of first data will be stored in lower address location, right? The consecutive higher address location will be held for the next. Whatever the memory devices you've been taking, like pen drives, hard drives, whatever, even 1 TB of memory device you have taken, each address location is able to hold only 8 bits of data, not more than that. Okay, 8 bits of data. Madam, why you are saying like that? We are storing one song in memory itself. Yes, memory can hold one song or more than, it depends upon the capacity of that memory. But I have been telling that each location of memory can able to store only 8 bits of data. Here the other companies like Motorola, other than Intel, have been using this big endian rule, where the lower byte of data will be stored in the higher address of data and the higher byte of data will be storing in the lower address of the data. Okay, here the same example we have been taking. So here the lower address byte, what is 29, right? This one is stored in the higher address of the memory. So in that particular memory, it will be storing. This is big endian rule. There is nothing difference between these two. But some companies using some of them. Intel is using this little endian rule and Motorola and some other companies using big endian rule. So this is all about the memory, how it will be stored in Intel microprocessor, and in that particular 8085 is using this little endian rule. Next, coming to the operating frequency will be the important thing, because it depends, it conveys the microprocessor how much speed it needs to be worked. So the next one is the clock generator. Before this 8085 microprocessor, the previous microprocessors have been using the clock generator. Apart from the this clock generator will be from the external source, but in 8085 it is in the external generator is not required, because the clock generator itself is implanted in the 8085 microprocessor. And what are the interrupts? How many types of interrupts are there in 8085 microprocessor? Here interrupts allows the microprocessor to respond to the external events. We can say the disturbance caused to that the program that causes the disturbance to the execution of the microprocessor is nothing but the interrupts. Are interrupts are necessary? Yes, 100%. Why interrupts are necessary? It will disturb the execution of program, no? But the thing is, if you are using printer, right? If you are using printer, I have given that it need to print 10 pages, but the printer, in hardware part of the printer, there is only 5 pages. So up to 5 pages it will continue to print, and after that it will throw one error message, out of paper, or in some cases out of cartridge. So like that. So what is that error message? It is nothing but the interrupt. So interrupts are necessary to stop the process for causing external or internal interrupts. So interrupts are of two types. Hardware interrupts, the interrupts that receives the interrupt signals through the pins. So in ICs, in IC of 8085, we are having 40 pin dual inline package. So by using these pins, if any interrupts have been generated, that interrupts comes under hardware interrupts. And software interrupts are the interrupts which we will be writing in the program itself. So in some programs, you would know that we are using HLT, halt. So such type of interrupts are considered as an software interrupts which we have been writing in the program itself. So here hardware interrupts of 8085 is having 5 hardware interrupts and 8 software interrupts. So trap is the most priority interrupt in 8085 when compared to the INTR, interrupt request. Next, another important thing of 8085 is it will be having 16 address lines, 16-bit address lines. So remember one thing, the address lines of any processor will be shows the capacity of holding the memory to that particular microprocessor. Suppose here we have been using 16-bit address lines. In these 16-bit address lines, it can access 2 power 16, 2 power n, where n is the address lines. So 2 power 16, which will be equals to 64 kilobytes of memory. So you can say that 8085 microprocessor can support up to 64 kilobytes of memory. So one of the example is we are using your mobile phones, right? At mobile phones, you can say that it will be having external 64, it will support 64 GB of external memory or 128 GB of external memory. So that will be depends upon the processor addressing lines. So if the processor is holding 16 address lines, it can able to access 64 kilobytes of memory. If the processor is having 20 address lines, which will be in 8086, so it can hold up to 2 power 20. Okay, so 2 power 20 of memory it can be accessed. So next one is 8-bit multiplexed address bus and data bus. So here one thing is data bus, as I already told you that here we are having how many data lines? So 8-bit data lines, and how many address lines? Address lines will be 16-bit, right? So these 8-bit can be started from D0 to D7, and these address lines will be from A0 to A15 because it is having 16-bit address lines. So in these 16-bit address lines, the higher byte will be A15 to A8 and the lower byte will be A7 to A0. As I already told you that 8085 microprocessor is having 40 pin IC. Actually, it is a 40 pin IC. So if we are using to access address lines, we need to give 1 pin for address lines, right? So from that, you can say that 16 pins are used to access the address line and another 8 pins will be used to access the data lines. Total 24 pins. Out of 40 pins, we have been using 24 pins to just pass the address and data. So due to that disadvantage, they have been multiplexing the lower address lines of 8085 with the data lines. So you can say that data lines and address lines have been multiplexed. If you want to access the address lines, you need to hold data lines. So vice versa. So AD0 to AD7. So address and data lines have been multiplexed, which reduce the utilization of the numbers. So only 16 pins will be used to address the same address lines and data lines. So next one is it can generate 8-bit input-output addresses. It can generate 8-bit input-output addresses. Input-output ports, which is used to access the input-output ports. As in the previous video, I told that microprocessor is not having any input-output devices in it and memory in it. So you need to access the external devices to give the input-output, and to access the memory also, we need to interface external devices. So how many external devices can we have access at the same time? So it depends upon the input-output ports. So in 8085 microprocessor, 8-bit addresses are used to access the input-output ports. So how many input-output ports it can access? Because it is a 8-bit, 2 power 8, which is nothing but 256 input-output ports. If we consider this an 8085, it can access DAC digital to analog converter, analog to digital converter, or input devices, keyboard. We can interface a mouse. We can interface output devices like monitors or printers. So how many input-output ports we can access? We can access 256 input-output ports in 8085 microprocessor. Next, So this is all about the important features of 8085. Until now we have discussed about the architecture which we have been using in the 8086 one human architecture, and what are the clock frequencies, total features of 8085. So in the upcoming video I'll be discussing the architecture and signal description of 8086. Thank you.